Welcome to a new module focused on a fundamental programming skill: file input and output, or file I/O. Up until now, our data only existed in memory while the program was running. If the program stopped, the data vanished. This module teaches you how to save and load data persistently to your hard drive. 1. Why persistence matters. Maybe almost every real-world application, from web servers to desktop tools, needs persistence. This means saving state, user settings, game scores, or large datasets so that the information remains available even after the program has terminated or the computer has rebooted. Files are the most basic and universal method for achieving this. 2. The key function, open parenthesis. In Python, all file operations begin with the built-in open function. This function returns a file object, which acts as a bridge between your program and the physical file on disk. It takes two main arguments: the file name and the mode, which specifies whether you intend to read, write, or append data. 3. File operation modes. There are three primary modes we will focus on for text files: R, for reading, W, for writing, and A, for appending. We must be careful with the W mode, as it will destroy the existing contents of a file if it already exists. 4. The golden rule: always close. After you finish reading or writing, you must call the close method on the file object. Failure to close a file can lead to resource leaks, and, critically, on many systems, data written to a file is only guaranteed to be saved to disk once close is called. To summarize, understanding these basics sets the stage for file mastery. Our next lecture, 23.02, Write string to a file. See you there. Welcome back. Let's get hands-on with file I/O by performing the simplest operation: writing a single string to a file. We will use the write method in the W, or write mode. 1. Using the open parenthesis and write parenthesis methods. First, we call open with the file name greeting.txt and the mode W to create the file object file_out. Then we use the write method on this object, passing the string we want to save. The write method returns the number of characters, or bytes, it successfully wrote. Finally, and most importantly, we call close to ensure the data is flushed from the buffer onto the disk. 2. Overwriting danger of W mode. Remember the critical feature of the W mode. If the file greeting.txt already exists, opening it in W mode will completely erase, or truncate, all its previous content. We demonstrate this by writing a second, shorter string to the same file. The original content is gone, replaced entirely by new message. 3. The with statement. Relying on manually calling close can be risky, especially if an exception occurs. The preferred, robust way is to use the with statement, which is a context manager. When Python exits the with block, it automatically ensures the file's close method is called, guaranteeing cleanup. This is much safer, and we recommend using it for all I/O operations. To summarize, you can now save simple strings. Our next lecture, 23.03, Read from a file. See you there. Welcome back. In the previous section, we successfully wrote data to a file. Now we perform the inverse operation, reading that data back into our Python program. We will use the R, or read, mode and explore 3 different reading methods. 1. Set up the sample file. For demonstration, let's assume we have a file named sample_data.txt containing 3 lines of text. We will use the recommended with statement for all our reading operations to ensure the file is closed correctly. 2. Reading the entire file with read parenthesis. The simplest way is using the read method without arguments. This method reads the entire content of the file from the current file pointer position into a single Python string. If the file is very large, be cautious, as this may consume a lot of memory. 3. Reading line by line with readLine parenthesis. The readLine method reads only the next single line from the file. Each call advances the file pointer. A key detail, the new line character, \n, is included at the end of the return string. We use the representing function here to show you those hidden characters clearly. 4. Reading all lines with readLines parenthesis. Finally, the readLines method reads the entire file, but instead of returning a single string, it returns a list of strings, where each element in the list is one line from the file, including the new line characters. This is often the most convenient way to process structured text data line by line. To summarize, you now know the 3 main ways to pull data out of a file. Our next lecture 23.04. Write multiple strings. See you there. Welcome back. In the real world, you rarely write a single fixed string. Instead, you typically deal with collections of data such as a list of usernames or scores. Today, we will explore the best ways to efficiently write multiple strings from a list into a file, ensuring each string appears on its own line. 1. Writing multiple strings via iteration. There is an approach is to iterate over your list using a for loop and call the write method for each item. Crucially, the write method does not automatically add a new line character. Therefore, you must manually concatenate the new line, \n, to the end of each string to ensure they appear on separate lines in the output file. 2. Using the writeLines parenthesis method. Python provides a more direct method called writeLines. This method accepts any iterable, like a list, and writes all of its string elements to the file in one operation. However, just like writeLines does not add new lines automatically. You must ensure that the new line characters are already part of the strings within the list before calling writeLines. 3. Writing lines without new lines. This example serves as a warning. If you call writeLines on a list whose elements do not contain the new line character, all the strings will be joined together in the output file without any separation. Always verify your input list or manually add the new lines during iteration. To summarize, you can now handle bulk writing operations. We've been assuming the file exists for reading, but that's not always true. Our next lecture 23.05. Check if the file exists. See you there. Welcome back. When reading files, a common problem is trying to open a file that doesn't exist, which immediately raises a file not found error. To write robust code, we need to check the status of a file on the disk before we try to open it. We use the built-in OS module for this. 1. The os.path module. To interact with the operating system's file system, we must import the OS module. We then access the path submodule, which provides several useful functions. The most crucial for this task is os.path.exists, which takes a file path or name and returns true or false. We can wrap our entire reading or writing logic inside an if block using this check. 2. Safe reading implementation. This demonstrates the correct pattern for safe file reading. We check if grades.txt exists first. If it does, and only then, we proceed to open it with the with statement in read mode. If it doesn't exist, we skip the open call entirely, preventing the file not found error and allowing the program to continue gracefully. 3. Checking for files versus directories. While os.path.exists is a general check, the os.path module also offers more specific checks. You may use os.path.as file to ensure the path points to an actual file, not a directory, and os.path.is.dir to check specifically for a folder. Using the most specific check for your task is usually best practice. To summarize, always check before reading or modifying, especially in critical applications. We have focused on reading and writing simple text strings so far. Our next lecture 23.06. Pickle. See you there. Welcome back. So far, we've only saved simple strings to files. But what if you have a complex Python object, like a nested list or a custom class instance, and you need to save its entire structure to a file? Manually converting it to text is difficult. The solution is pickling, which is Python's term for serialization. 1. What is pickling? Pickling is the process of converting a Python object hierarchy into a byte stream, which can then be written to a file. This byte stream represents the object state in a way that Python can later use to perfectly reconstruct the original object in memory. 2. Using pickle.dump parenthesis to save objects. We first import the pickle module. When pickling, you must always open the file in binary write mode, specified by WB. The B is crucial because pickle data is raw bytes, not readable text. We call pickle.dump, passing the Python object, our dictionary data underscore object, and the file object. The entire dictionary structure is immediately converted and written to the file. 3. Binary versus text files. If you try to open the resulting user_data.pkl file in a text editor, you would see a stream of unreadable characters. This is the difference between text files, which use readable characters, and binary files, which store raw bytes optimized for machine processing. Pickled files are binary. To summarize, you can now save any list, dictionary, or instance of a custom class instantly. Our next lecture 23.07. UnPickle. See you there. Welcome back. In the previous section, we successfully serialized, or pickled, a complex Python object into a binary file. Today, we complete the cycle by learning how to retrieve that object and restore it perfectly in memory using unpickling. 1. the pickle.load parenthesis function. To unpickle an object, we must first open the file in binary read mode, specified by RB. We then call pickle.load parenthesis, passing the file object. This function reads the entire binary data stream, converts it back into the original Python data type, whether it was a dictionary, a list, or a custom class instance, and returns it. Notice that the type of the loaded object is exactly the same as the original object we saved. 2. Using the loaded object. The most powerful aspect of unpickling is that the loaded variable is a fully functional Python object, complete with its original methods and data structure. Because our saved object was a dictionary, we can immediately access its keys and use Python functions like max parenthesis on its values, just as if we had defined the dictionary within the current script. 3. The security warning. While powerful, pickling comes with a major security risk. The Pickle protocol is designed to execute arbitrary code during deserialization. Therefore, you must never unpickle data received from an untrusted source, as it could lead to remote code execution. Only load data that your own application has securely saved. To summarize, pickling and unpickling provide a seamless way to save and restore complex Python objects. We've learned the basics of text and binary I/O. Our next lecture 23.08. More about red. See you there. Welcome back. In our earlier section on reading files, we used methods like read to load everything at once or readlines to get a list. Today, we focus on more efficient and nuanced reading techniques, particularly for large files, by understanding the file cursor and iterative reading. 1. The file cursor. Think of the file object as having a cursor or pointer that tracks your current location in the file. Every time you read from the file, this cursor advances by the amount of data read. For example, if you read 10 characters, the cursor moves 10 positions forward. The next reading operation starts from that new position. 2. Efficient iterative reading. For very large files, the most memory-efficient way to read is to use the file object directly in a for loop. When you iterate over the file object f, Python automatically reads one line at a time, keeping only that line in memory. This is superior to readlines, which loads the entire file into a list at once. We use strip here to remove the trailing new line character, \n. 3. Reading a specific byte count with red end parenthesis. You can pass an integer argument, n, to the read method to specify exactly how many characters or bytes to read. This is useful for processing files in fixed-size chunks, common when dealing with structured data formats. Notice how the second read operation starts exactly where the first one left off, thanks to the advancing file cursor. To summarize, you now have tools for reading files of any size efficiently. Our next lecture 23.09. Right? See you there. Welcome back. We've already used the write mode, W, but it's crucial to fully understand its power and its potential dangers before moving on to other modes. This section reinforces the concept of writing to a file and emphasizes the destructive nature of the W mode. 1. The purpose of W mode. The W mode is used when you want to start a file from a blank slate. Its behavior is simple. It opens the specified file and places the file cursor at the very beginning. If the file does not exist, it is automatically created. If it does exist, it is truncated, meaning its entire content is deleted, ready for the new data. 2. Example, file truncation. Let's see the truncation in action. If log.txt already has content, opening it in W mode instantly wipes out that data. When we call write, the new text is placed at the start of the now empty file. This behavior makes W mode suitable for tasks like saving configuration files or generating fresh reports. 3. The write parenthesis method return value. As a quick review, remember that the write method returns an integer representing the number of characters, or bytes, that were successfully written to the file. This can be useful for debugging and tracking data volume, but for the most part, you can safely ignore the return value and rely on the operation completing successfully within the with block. To summarize, use W mode with caution. Now, what if you want to keep the old data and just add new data to the end? That is the job of the append mode, which we will learn next. We will explore the mode and confirm that it adds new data to the end of the file without erasing the original content. Join me in lecture 23.10. Append. See you there. Welcome back. While the W mode is useful for creating new files or overwriting data, it is disastrous if you need to preserve existing content, like in a running log file. For this purpose, we use the append mode, represented by the letter A. 1. The purpose and behavior of a mode. When you open a file in append mode, Python automatically places the file cursor at the end of the existing content. Any data written using the write method will be added after the previous data. Just like W mode, if the file does not exist, the mode will create it for you. 2. Example, appending data. Let's look at the result. If notes.txt contains first note, opening it in a mode preserves that line. When we call write twice, the new lines are simply added to the end. Since we are adding multiple entries, it is vital to remember to manually add the new line character, \n, at the end of each string to ensure proper line separation in the file. 3. The difference between W and A. The difference is crucial. When comparing W mode and A mode, their behaviors when the file exists are opposite. W mode truncates or deletes the content. A mode preserves and adds to the content. Both modes will create the file if it doesn't exist. To summarize, append mode is your go-to for log files and continuous data collection. We have covered all the fundamental file operations. To wrap up this module, let's learn a practical file processing example. Counting the lines in a file efficiently. Our next lecture 23.11. Count lines. See you there. Welcome to the final lecture of our File I/O module. We've learned reading, writing, and appending. Now, let's put our knowledge of efficient reading to a practical use case. Reliably and quickly counting the total number of lines in any text file, regardless of how large it is. 1. The inefficient approach. You might initially think to use the readLines method and then count the elements in the resulting list. While this works for small files, it is highly inefficient for large files. Why? Because readLines loads the entire content of the file into your computer's memory at once. If you have a gigabyte file, your program consumes a gigabyte of RAM just to count the lines. 2. The efficient approach. The most memory-efficient solution is to iterate directly over the file object, f, as we learned in section 23.08. This process reads only one line at a time, discarding it before loading the next. We simply use a counter variable, line_count, which we increment in each iteration. This method uses a constant, tiny amount of memory, regardless of the file size. 3. Creating a reusable function. We can package the sufficient logic into a reusable function, count_line, which also includes error handling for files that don't exist. For maximum performance, Python programmers often use a generator expression. There's someone for line in fpart, which is highly optimized for this specific task. Notice we also wrapped the file operation in a try_except block to gracefully handle the file not found error. To summarize, iteration is the golden rule for large file processing. You have now completed the entire files section. Our next module transitions to a completely new and powerful topic: regular expressions, the language for pattern matching in text. Okay, we will go to the next section, section 24. Next, join me in lecture 24.01, Introduction. See you there.